What's up, friends? Dan Vega here, and today we're talking about Spring Boot 3. Unless you've been living underneath a rock, and oh my gosh, if you are, ask for help, please. Spring Boot 3 and Spring Framework 6 have been released, and wow, they are packed full of really great features. Today is my What's New in Spring Boot 3 video. So what we're going to do is we're going to create a new project using start.spring.io. We'll take a look at some of the major theme features such as moving to Java 17, Jakarta EE 9 and 10. We have a big theme around observability. And of course, one of the big headlines is being able to generate native images using GraalVM. There are also a bunch of other little features, or maybe not headline features, that I find fascinating. And some of the supporting projects have some really great features in them as well. So that's what we're going to do today. This is not an in-depth tutorial into every single feature. This video is long enough. This is more of an overview of, hey, here are some of the things that are new in case you aren't aware. So with that, let's just get in, write some code, and start talking about Spring Boot 3. Oh my gosh, I'm so excited this is finally here. If you want to read more about Spring Boot 3, there is a really good blog post here about Spring Boot 3.0 going GA. A just kind of recap of what happened in this release. That will also point you to the release notes. The release notes are a great way to kind of get caught up on what's new in a release, what's been deprecated, what's been removed, all the little features. So go ahead and check out that blog post and the release notes. But what we're going to do here is we are going to create a new project using Spring Boot 3.0, and we'll go through and take a look at some of the new features, some of my favorite new features, by creating a project and going through and just kind of pointing them out as we go. So we are going to use Java. The Spring Initializr has changed a little, if you haven't noticed. The default is now Gradle, and there's actually two versions of Gradle, Gradle Groovy and Gradle Kotlin. I'm going to choose Maven, and we're going to use 3.0.0. I'm going to go ahead and fill this in. We'll say dev.danvega, and let's just call this a blog. We're going to work with the domain of a blog. So we're going to choose packaging of jar and Java 17. Just a reminder that Spring Boot 3, Spring Framework 6 now require a baseline of Java 17. So we need to be on at least that. Okay, so we're going to do a bunch of things here, but I want to just start out pretty simple. We can go ahead and add some dependencies later. I'm going to build a REST API. I'm going to use Spring Data JPA, and I'm also going to need a database. I'm going to talk to an H2 database. We are going to use a bunch of other things like Spring Security. We'll talk about Micrometer and some of the observability changes. We'll bring in the actuator. We'll talk about, a whole bunch of other things that we need to, but I don't want to kind of get worn down here by adding all these dependencies now. This is all we need to get started. So let's start with that, and then what I'll do is go ahead and generate this project. And I'm going to go ahead and open this up in my favorite IDE, IntelliJ. You can open up in whatever text editor or IDE you're most comfortable using. All right, so here we are in IntelliJ. And before I get this question asked to me, I know somebody's going to ask it because I've been getting it a lot lately. The theme for this is the new UI in IntelliJ 2022.3. And I believe this is the GitHub dark theme. I'll have to check, but that new UI is in the new version of IntelliJ. That's how I'm getting this look and feel. So with that, let's go ahead and talk about what we're going to do here today. So again, we're just going to kind of build an app. It's not a real app. We're just kind of like taking a look at all these different features that I want to cover today. So with that, all the source code that we're going to go over today will be in the GitHub repository. You can find the link for that in the description below. The first thing I want to do is take a look at the pom.xml. So we can see that we have declared version 3.0.0, and we are using Java 17. That is kind of, again, one of the big major headlines of Spring Boot 3.0. If you go into the Spring Boot starter parent, so on a Mac I'm command clicking, and you go into Spring Boot dependencies, you can get a list of all the dependencies that we've included in here. That is why when you include something in your main POM as a dependency, you don't have to declare a version because we've kind of declared that for you. We've said we found this to be the version that works best. So if you go into the README for this repository, you'll see I've listed a bunch of information in here around different versions of things. Now, again, one of the things here is Java 17. If you're coming from something like Java 8, not only are you getting huge performance improvements, you're getting a lot of security features, security updates, as well as new features for developers, right? All the way dating back to like Java 9, if you're coming from that far back, from 9 to 17, you're getting things like JShell, local variable type inference using the var keyword, an HTTP client, switch expressions, text blocks, records, pattern matching, sealed class, a whole bunch of really great developer productivity enhancements and features. So I think that's the big start for me is Java 17. Now, the next one is Jakarta EE 9/10. Now, why are you putting two versions in there, Dan? So let's talk about this. Let's go ahead and run this application. And I want to take a look at the console here. And if we look in here and we see that Tomcat was started, we see that Tomcat is now on 10.1.1. So this is part of the reason that you'll see when we talk about Spring Boot 3 and the Jakarta EE version. Jakarta is, so we're using 9 and 10 in different places. It might be a little confusing, but let's talk about why both are listed. So Spring Boot 3 upgraded to Tomcat 10.1, as we see here, since 10.0 was end of life already. This has a dependency on Servlet 6. The goal now is to provide a set of EE10 providers in Spring Boot 3, or as far as possible, while retaining an EE9 baseline for optional downgrades. Example, Jetty 11 still uses Servlet 5. So that's why we see, if you see 9 and 10, that's a little bit of both. What it boils down to is that we can support either 9 or 10 at runtime, but only 10 in a test suite that may use something like Servlet. This is because the Spring-provided Servlet mocks have a Servlet 6.0 baseline now. And again, this restriction really only applies to like mock-based servlets. Tests using something like test rest template are not going to be affected. So that's the move to Jakarta EE 9 or 10. What implications does that have? Well, if you're in your own application and you're upgrading, you'll have to change the namespace. And what is the namespace? Let's take a look at that, all right? Let's start creating our application by creating a new model. So I'm going to create a new package in here. We'll call this model. And I'm going to create a new Java class called post. Inside of post, we're using Spring Data JPA. I'm going to mark this as an entity. And right away, you see we bring in Jakarta.persistence.entity, where this would have been JavaX.persistence in the past, right? So now if I want to, I can say @ID, private integer ID. And again, that ID is coming from Jakarta.persistence. So private, let's just say user ID. Whoops, probably need an integer there, Dan. Let's say we have a title. Man, my typing is just all off this morning. That's okay. Private string body. So then what we'll need is a noarg constructor. We need that for JPA's sake. And then we'll go ahead and get a constructor where we take all args. So there we go. And then we'll just generate some getters and setters. And I know the question is, why aren't you using Lombok? And yes, I liked Lombok for a while. I just don't see the need for it now. I don't mind generating this from the IDE. And no, you can't use records. We are on 17. Currently, JPA doesn't support records. Again, that's because it has this noarg constructor. Records are immutable, so we have to like set everything, and then we can't change them later, right? So that is the reason for that. But again, you could see using something like the IDE, it doesn't take a long time to kind of generate that data. All right, so that's really what I wanted to show here, that when we're pulling in the Jakarta stuff, we are using the correct namespace. Again, if you're upgrading, you're going to have to change javax.persistence to jakarta.persistence. So with that, we brought in a whole bunch of kind of updated libraries, right? The list is in the README below or in the release notes for the full list, but we're getting updates to things like Hibernate. So we're on 6.1 of Hibernate. We're on Hibernate Validator 8.0. We're on Jackson 2.14. We're on R2 DBC 1.0, which is great. Tomcat 10.1, Timeleaf 3.1.0. So check out the release notes for all the updates, but that's really great to see. And I think I've said this on Twitter before, I've said this in presentations before. One of the things that I'm most excited about in this move to Jakarta is all of these APIs that have been stagnant for years now. We get to see them evolve. These APIs are going to evolve and improve and get better and get things added to them. So that, for me, is most exciting. Even though we need to put in a little work and change some namespaces, it's going to be good for us moving forward, so I'm excited about that. The next big feature that I want to talk about is the headline of Spring Boot 3.0 and Spring Framework 6, and that's GraalVM native image support. This has been one of the biggest, if not the biggest, feat that the Spring engineering team has taken on. Because again, it's not just the framework itself. It's not just Spring Boot. It's the entire ecosystem of projects that need to be able to support this. So kudos, hats off to the Spring team on this amazing release and this feature in particular. So Spring Boot 3 applications can now be converted into a GraalVM native image, which can provide significant memory and startup performance improvements. This will require GraalVM 22.3 or later and the native image build tools plugin, but you can read more about that in the documentation if you like. So there's here just kind of an introduction to what GraalVM native images are, the differences with JVM deployments. So the thing with this is it's not for every single workload. If you have like this high throughput, always up application, then maybe that's not the case. We've been asked this a lot on Spring Office Hours lately. When should I use a native image? You know, there are certain workloads that do work better. Things like serverless functions or cloud native development, depending on, you know, what the workload is. So I would say, you know, figure out if it's right for you. If it is, go ahead and test it out. Maybe it is right, the right situation. Maybe sticking with the JVM in your case, in this particular application's case, is the right move. It's really about you kind of testing this out and figuring out which workload is right. The JVM is still great. It does so many great optimizations at runtime. But again, in certain situations, this is going to be a key difference going forward. But what I want to get into is developing your first GraalVM native image application. So that's what we're going to do. We have an application and we want to generate a native image. So we have the sample application, which we do now. And basically you can build a native image a couple of ways. One, using build packs. So if you want to use build packs, you can. There's a note in here. The builder used for these images is Paketo Build Packs Builder Tiny. It has a small footprint and reduced surface attacks, but you can also use Paketo Build Packs Builder Base or Builder Full. This also depends on what architecture you're using. So I'm on a Mac OS, I'm using ARM. If you're on Intel, you know, those two are different builders, build packs that it's using. Currently, if you do it on Mac OS, you'll have to check out my coworker Deshaun's article on how to get this working. If you're on Intel, it should kind of work out of the box. So there's some system requirements, how to use Maven. And then if you want to build that particular build pack one, you can just say you're using this -P to switch to the profile native. And then you're running the Spring Boot build image. The same Maven goal that you would run before, you're running now. You're just using a different profile. So that's cool. So you can also do this in Gradle. And then you can go ahead and run this example. What I'm going to do is actually run this using the the native image using the native build tools. So let's take a look at what that looks like. So if I go into my terminal here, and I say java-version, you can see we are using GraalVM 22.3. So what I can do is I can say maven-p. Again, we're going to switch to the native profile. But we're going to use the native tools now to compile this application. So you're going to see it's going to bring a whole bunch of stuff down because I haven't done this yet here. It's going to go through the native compilation. Now, again, there are trade-offs for this. This is going to take a little bit of time. But once it's done, we'll have a native executable that'll run on this architecture, this machine, so we could push this somewhere else, and it's going to be much smaller in memory, which is really cool to see, and a much faster startup time. So I've done some videos on serverless Spring. So this would be a perfect scenario for that if you wanted to build a serverless function using Spring Boot and Spring Cloud Function, build a native image, push this to a provider like AWS or Azure or Google Cloud. Now you have this smaller footprint and this image that can start up really, really fast, this native executable. So again, in certain workloads, this is going to be really good. I'm going to not let you watch this whole thing and get bored watching this build. So through the power of editing, we will jump ahead to when it's finished. All right, so as you can see, it took about 2 minutes. This isn't something you'll do in your inner loop development all the time. This is something that would happen, say, in a CI/CD process to generate that native image. But now let's look in our target directory. If we look in here, we can see we have this blog. This is the native image. So if we wanted to run this, we can just say target blog, and you'll see that it runs up. Whoop. We got something in use already. That's okay. Let's see. What do we have running here? We have, oh, this application is already running. So that's why. So let's clear this and just run this again. And you see how fast that starts up. That was instant, 0.082 seconds. Now, again, this is a pretty trivial example. So what did we gain here? Maybe a second or two. But as your applications get a little bit bigger and a little bit heavier, this matters. The footprint of the memory matters. The startup time matters. If you can cut a few seconds off and you have 1,000 different instances starting up, imagine the savings on your cloud bills that you're going to be able to get. So pretty cool to see. There's a whole lot we can go into here, but I just wanted to give a brief introduction into generating native images with GraalVM in Spring Boot 3. All right, so now I want to go ahead and continue to build out our application, and that way I could show off a couple other little features that I'm really excited about. So I'm going to create a new package here. We're going to call it repository. And inside the repository, I'm going to create a new Java class, and we will call this the post repository. Now, again, this is an interface. So one thing I want to point out here is that Spring Boot 3 uses Spring Data 2022, and there have been some really good additions there. And actually, we'll jump over to the browser in a second and take a look at a bigger list, but I just want to show off one thing here. So in the past, we might have done something like extends CRUD repository. So CRUD repository, and then what is the type? It's a post, and then it is the ID type is an integer. So in CRUD repository, we have all these methods that allow us to do things. But one thing that's always been a little bit quirky is find all returns and iterable. And we're used to working with things like lists. So now you have to figure out how to iterate over this or turn that into a list. And it's just one of those little things that you would like to change. So what the Spring Data team did, was add a new list CRUD repository. So again, we can still use post as the type, and then the integer is the ID type. But if we look at list CRUD repository, you see that it still extends CRUD repository, but now it adds a few methods here, and these all return a list. So save all now returns a list. find all now returns list, and find all by ID now returns list. So what does this really mean? Well, this means that when I go to create a controller, so let's create a new controller here. We'll say controller, and we'll say new Java class, post controller. And we're going to mark this as a REST controller. We're going to have a request mapping of /API/posts. And in here, we're going to get an instance of that post repository. So we'll say private final post repository, post repository. We'll get an instance of this through constructor injection. Now what we can do is we can have a get mapping for public list of posts, find all, and now we can say, hey, let me use that post repository, and I want you to go ahead and find all. Now, if you did this before, it would yell at you and say, hey, CRUD repository is returning an iterable, and you're trying to return a list. Again, just one of those little nice things that makes everything line up a little bit easier. Now, what this does mean is you can see that in the list CRUD repository, we're basically extending CRUD repository. So there's two of these different types of CRUD repositories, right? There's list and there's regular CRUD. So what this means is if you were going to use something like paging and sorting repository, this takes a post and an integer just like the other two. You could see that this extends repository now. While this used to extend CRUD repository. Now we don't want to do that now because we want to give you the choice to extend either CRUD or list. So if you want to extend, you can go ahead and extend the other one as well, list CRUD repository, and that would go ahead and take a post and an integer as well. So that is just a small change, but something that, it's just those little things that I always love. And the Spring Data team is really helping us out there and giving us these nice little features here. So if you look at the Spring Data 2022 release notes, you'll see kind of the general themes. Again, they've upgraded to Java 17 baseline, Spring Framework 6, Jakarta 10, and you'll have all of the ahead of time processing and all of the hints to create your GraalVM native images. There's a bunch of observability integration with micrometer and micrometer tracing. So we'll look at observability in a little bit, but all of that's been baked into the Spring Data project. And then a couple things right here that we just talked about. So there's now new variants of the CRUD repositories. We saw the list CRUD repository. There's also the list query DSL predicate executor and the list query by example executor. These return list methods that return multiple entities. So because of that, sorting repositories no longer extend that CRUD repository. So we saw that with this, the other ones are kind of following suit. So that just means that you must extend that explicitly. And then there's just some changes to behavior about the delete methods and revised constructor discovery for Java records. So a whole bunch of really great stuff. I'll leave a link to the Spring Data release notes. Just thought I wanted to point out those. Again, kudos to the Spring Data team for those changes here in Spring Boot 3. The next new feature in Spring Framework 6 that I want to talk about is HTTP interfaces. Before we can do so, though, I want to step back and talk about our application. We'll go through a normal progression of how we might build this out in previous applications, and then we'll see where HTTP interfaces really come in and save the day. I want to load a bunch of blog posts, but I'm going to get this from another service. This is not coming from this particular database. I want to load some initial blog posts from another service. So let's take a look at that service. The service is a public API called JSON placeholder. And if we come down here, we can see that we have JSON placeholder comes with common resources like posts. And you could see this is the post that I want to go ahead and load. And this is why I modeled my post entity to look like that. So I had an ID, a user ID, a title, and a body. So what I want to do is I want to take this and I want to go ahead and import those into our application. So what I'm going to do is I'm going to create a new service. We'll call this post service. Oops, I'm sorry. I meant to call this service. And inside of service, I'll create a new Java class. We'll call this post service. And I'll mark this with the @service annotation so this gets picked up. So what I want to do is I want to create a method that returns a list of posts. We'll call this load posts. And so somehow I got to reach out, let's say call the JSON placeholder service and return the list of posts. So how would I do this? So in a normal application before Spring Boot 3, I basically had two options. Well, you could go low level and use some other options, but in the Spring world, we have two options. One, we could use a REST template because we're in the Spring MVC world and we don't care about non-blocking IO. We are in a blocking servlet world right now. So REST template works fine. If you were in a reactive application, you could use something like the web client, but REST template works fine for what I want to do here. So I'm going to go ahead and say private final. Actually, let's say REST template. And actually, I do want to mark this as final. So what I'm going to get is this through constructor injection. I don't actually have a bean of type REST template. So I'm going to create one here in my main application class because this is a configuration class. And I'm just going to say REST template, return new REST template. So that works. That should satisfy that. And now I have a REST template that I can use. So I want to say REST template .exchange. So when you're returning like a list of things back, it gets a little quirky. You need to return something called a parameterized type reference. Say that a couple times fast. So we're going to pass in the URL that we need to. So that is that JSON placeholder. This is going to be a get. So we're just getting that. And can we get these on separate lines? Yeah. And then the request entity is going to be null. We don't care about that. And then you could see the response type. We're going to use that new parameterized type reference, which is going to be a list of posts. And that looks good. Does that look good? Yes, it does. So now what I can do is just return we need to set a local variable here. Sure, we'll call it exchange, return exchange dot get body. So that should give us our list of posts. Okay, now that we have this load posts method, we can go ahead and use this somewhere to load all of these posts into our database. To do that, we're gonna have to do a couple things. I think the first here is I'm gonna come in here and I'm just gonna rename this to application.yaml. I'm gonna use a YAML file in this particular demo because we're gonna be doing a bunch of properties later when it comes to observability. But the first thing that I wanna set is the data source name. So we're gonna set this to blog. So we have a spring.datasource.name. We also want to generate a unique name false. So we're going to set that. So now we have a database connection because we're using that H2 in-memory database. But now I need a way to go ahead and call that post service when the application loads and feed all of those posts that I just grabbed into the database. So for that, I'm going to create another bean here. We're going to call this, this is of type command line runner. So again, if you're new, a command line runner is a functional interface. This means that there's only a single method in here, a single abstract method, and that it is a great target for a Lambda expression. So we can just go ahead and use a Lambda here instead of implementing this interface and overriding this run method. So we're going to call this command line runner. We're going to get an instance of our post service here because we're going to need that to go ahead and insert or call our load posts, and then we can go ahead and use our post repository to save that. So let's also get our post repository instance in here as well. So this is going to return this, and here we go. So now the first thing I want to do is load all of those 100 posts from the JSON placeholder service. So to do so, I'm going to say post service, and then we're going to call the load, oops, wrong one, post service dot load posts, and I'm going to create a var from that, and that will create a list of posts called posts. Once I have those posts back, I can use the post repository to save all of those posts. So I'm going to pass in post, and now I can go ahead and introduce a local variable if I want to there. Sorry, I didn't want to do that. I wanted to use post repository.save all posts, and I don't need a local variable because we're not going to do anything with it. So now at this point, when the application loads, we're going to call post service load posts. We should get back those 100 posts from the JSON placeholder service. And then when we return that, we'll just go ahead and call our repository.saveAll and persist those posts to the database. So let's run our application. We didn't get any errors, so that's a good thing. So again, one thing I want to point out here is we talked about this earlier, but we are on the latest and greatest version of Hibernate. So we're using 6.1.5. So we are up onto 6. There's a whole bunch of good features on 6 going forward. So if you want to check out the Hibernate documentation on that. We have our connection to our JDBC H2 in-memory database called blog with the default user of SA. So what I want to do is, we actually didn't enable the, we want to enable the H2 console. So let's rerun this application, and then we could go ahead and jump in there and take a look at the database. All right, so I'm gonna go ahead and use the blog database. The username is SE. We can test that, it looks good. If we jump into the post table, we can see that there are now 100 rows in there. So great. So that tells me we were able to call out to the JSON placeholder service. We were able to then use those posts and load those into our database. All right, so that worked. There's actually nothing wrong with that code. If you want to continue to write that code, go ahead. But what's happening here is we basically are telling Spring, hey, I want a list of posts. Here's the service that I'm going to call. But now you need to do this dance with the underlying HTTP client by using this REST template and calling this exchange method and then figuring out which method to use, which parameters to call. If you look at the API, there's just a ton of methods in there, a whole bunch of overload methods. What do I use? I just want a list of posts. And that's really where HTTP interfaces come in. The Spring framework lets you define an HTTP service as a Java interface. So the same way that we do with our repositories, with some annotated methods for things like HTTP exchanges. You can then generate a proxy at runtime that implements this interface to perform those exchanges. This really helps simplify any HTTP remote access, which often involves this facade that's wrapping the details of using that underlying HTTP client. So what I want to do is move away from the post service. We're going to keep this class in place so you can see it in the repository. But what I want to do is move away from this. All right. We're going to say we're not going to do that here. We'll come back to this in a second. But what I want to do is just declare an interface that has the methods that I'm interested in with the service that I'm interested in talking to. So what I'm going to do is create a new Java class here. We're going to call this JSON place. I'm going to actually placeholder service. And again, this is an interface. And what we're going to do here is we're just going to define the methods that we're interested in. So we know that we want a list of posts. We're going to call this load posts. And how are we going to retrieve this information? Well, in this particular one, this is a GET. So this is going to be a GET exchange. So there are also things like post exchange, delete exchange, etc. So we're using the GET exchange to slash posts. So there'll be a kind of a baseline URL for this service somewhere. So if we look back in our post service, this can be the baseline URL. And then in this particular case, all we want to do is call slash posts off the base, and that is what we're going to call to get this list of posts. Then what happens is we're going to write a little bit of code, and this at runtime will get turned into an implementation that we can now use. So this is a lot easier, right? All we're doing is defining one single method here with, again, this is an interface. We're defining an abstract method here instead of what we did before, which was try to figure out that song and dance of like, what method do I call? What parameters do I get to pass? This weird thing with the parameter type reference, we don't have to do any of that anymore. We get this simplified method here. So how does that turn into what we need it to turn into? So we do need to bring in the web client because the web client is what's going to kind of drive this. So what I'm going to do is go into my pom.xml, and I'm going to have a dependency on Spring Boot Starter Webflux, and that's it. I'm going to go ahead and click save or reload. Make sure that's okay, and it seems like it is. All right, and so what I want to do here is use the web client .builder. Did we not load yet? Web, oh, that's why. Let's bring that in. All right, so we're going to use the builder. We're going to set a base URL. Again, we're going to go back to that post service. I'm going to set this as the base URL, not the slash posts, right? And actually, I don't want that. I just want that. So we're going to set our base URL to that. And we're going to say build. And we can introduce a local variable here. Let's go ahead and call this client. And then what we'll need is something called an HTTP service proxy factory. We're going to go ahead and call builder on that. We're going to say web client, web client adapter. I don't know why that's not coming in. There we go. So for client, we're going to use client and build. And finally, now that we have that HTTP service proxy factory in place, what I can do is I can create an instance of that JSON placeholder service. So I could say JSON placeholder service is equal to factory.createClient. Now all we're doing is creating that client. And we're going to pass in that type. So JSON placeholder service.class. So now I know you're probably saying that this seems like a little bit of overhead, and it might be, but this is going to be consistent for each one. So what you could do is just come in here and create for me, I create like a live template in IntelliJ to output this every single time so that I don't need to go in and type this. So once you have that boilerplate down, you get this JSON placeholder service. You now have an implementation of that interface. So what does that mean? So that means now we can just say, hey, JSON placeholder service, go ahead and load posts. And that is going to give me back a list of posts. Now I can come back to my post repository.saveAll. If we go ahead and run our application, everything looks okay. Actually, yeah, that's a different error, so don't worry about that. Let's go back to the browser, check out the H2 console, connect to that, look at post, and we still have our 100 records. So cool. So that is HTTP interfaces, allowing us to just declare this interface and the methods that we care about. So again, this is working with a public API like I have in this instance. Maybe you're calling another service within your application, a microservice. So you can just declare a service that is going to call that service, and then you list out the methods and the exchanges that are going to happen there. And then we will turn this into an actual implementation, and you don't have to worry about all the like nitty-gritty, which method am I calling, which parameters am I passing. This just is going to work for you. The next really big theme in Spring Boot 3 and Spring Framework 6 that I want to talk about is observability. So observability is the ability to observe the internal state of a running system from the outside. This really consists of 3 pillars, which are logging, metrics, and traces. For metrics and traces, Spring Boot uses micrometer observation, and more importantly, distributed traces are now wrapped up into micrometer. Whereas in the past, we might have reached for a third-party library like Spring Cloud Sleuth. So this is all rolled up into micrometer, which is really good, gives us one place. The other big thing is this is a consistent API that the framework is now using to gather metrics and traces about what's happening in your application, as well as this API that you can now use in your application. So there is a lot to cover here. I cannot cover all of this in this short video. We're going to just take a look at a couple things. I'm going to leave this a link to the reference documentation. This is a really good place to start. I would read through here, understand about these kind of low cardinality key values, high cardinality key values. There's a tip here for the JDBC observability, which we are going to do. Go ahead and take a look at that. And then the micrometer observation documentation is really the next place to start to understand how all of this works. So for me, I'm going to come into the PALM here. I'm going to add some dependencies. Again, if you go ahead and add these from like the Spring Boot starter or from start.spring.io, you can kind of pull these in as you're building out your application, but we're doing this as we go. So I'm pulling in a couple things. Again, this is what I got from the documentation. The other thing I need to do is I need the actuator. So actually, let me go back to here. We didn't pull in the actuator yet, did we? No. So let's say dependency actuator Spring Boot starter actuator. And let's pull that in. So now that we're using actuator, we're starting to collect all of these metrics. What happens is when these things are being instrumented behind the scenes for us, we now need a place to kind of view some of these things, like these traces. And so what I'm going to do is use a tool called Zipkin. So we've pulled in the dependencies that we need to kind of connect to Zipkin. I need to run a local instance of Zipkin to get this up and running. So to do so, I'm going to run a Docker compose file. So dockercompose.yaml. I'm going to go ahead and copy and paste this in. But what this will do is allow us to start up an instance of Zipkin. So let's just go into our services. I want to see if this is already running because I've done, oh, yep. So this is already running. Let me make sure this is stopped. All right, now that we have Zipkin running, let's head over to our post controller. I just want to take a look at this. So what we're going to do is we're going to make a few changes to our configuration, and then we're going to launch our application, and we're going to go hit the /API/posts endpoint. And we're going to see that some metrics and traces are being gathered for us underneath the hood thanks to the framework, right? So this is one place that we're going to kind of get all of this out of the box for us just by including the actuator and the right dependencies. And then what we'll do is things like this that we are going to another service for that we are calling here in our command line runner. This is not being instrumented. This is our own code. So we'll have to find a way to do that. And lucky for us, as I said at the beginning, this is all that single consistent API that the framework uses and that we can use as well. So let's take a look at this. I think the first thing we need to do is go into our application.yaml, and I've added a few things here for configuration, just making sure that the health endpoint is on, that we're including all the endpoints. This tracing sampling probability is a value of 0.1 to 1.0, and it's how much sampling do we want to take. Here I'm in a dev environment. I'm just saying always sample, always collect this data for me because I want to see it. So with that in place, I'm going to go ahead. Oh, I don't want to run Docker compose Dan. That's already done. What I want to do is I want to run this. So go ahead and run that for me. And if this starts up okay, and it does, let's head over to the browser. And I'm going to go to localhost 94111. That's what we set Zipkin to run on. So Zipkin is this tool. We can look for traces. If I go ahead and run a query, I'm going to see a whole bunch of traces in here. These are just connection traces that are being done. These are instrumented thanks to the JDBC call, one of the dependencies that we included on there. So if we go in there, we can see that we have a connection to an H2 database. We can see we kind of select to see some things going on. And then down here, we're inserting into the body, title, user ID. This is because the repository itself is instrumented. So when we say post repository.save all, that's instrumented. This is not. So we don't see anything for this call. So what I want to do now is just go to localhost 8080 /API/posts. And now I see all of the 100 posts that were loaded in. So now if I go back to Zipkin and run this query, now we're going to see that call being made. So if I jump in here, I can see some information about this. I can see no tags. Here's the URL. It was a GET method. It was successful. The status code is 200. Here's the URI. We can see that this was the call. This was the total duration of that call. If you start to drill into it, and it does a whole bunch of different things, we get instrumentation on those things. This just happened to call a repository and return all of the records from the database. So we can see our connection again. We can see that we are selecting from posts, and hey, here's the row count. We get 100 rows back. So again, that was just that find all method. So cool. So far, so good. We're getting a whole bunch out of the box, but now we want to go ahead and do some things ourselves. So how can we do that? Again, back in the documentation, you can take a look at this. I'm going to go ahead and delete that particular call. And what we're going to do here is we are going to say observation. And now from the observation, we can do something called create not started. This is going to take a string name and then an observation registry. So the name is anything that we want to add here. So I'm going to just say this is JSON placeholder load. Actually, let's say load posts. So now I need an observation registry. Luckily, it is one has already been created for us, and it is in the Spring context. So I can just add a argument here to my command line runner. And because it's there, now I can just say observation registry. And now we need to do a couple of things. One, we could set a low cardinality key value. So if we set a low 1, we could say just some value, and we could set a value for this. I'm just going to say 88. Again, these are kind of like tags that you would want to track, right? What do we want to track here? So I'm saying that. And then I'm going to go ahead and observe something. So what are we observing, and why am I getting this funky, oops. Let's close this. Why am I not getting, anyways. Okay, so now we want to observe something. What do we want to observe? So this, if you look at this, takes a supplier. So we could come in here and we could say, use a lambda here and then say JPS.load posts. But because we are not passing an argument here, we can also just go ahead and use a method reference. So I'm going to do that. So JPS load posts, and now that works. So what we're doing is we're using the micrometer observation API that the framework and all the projects across Spring are using. We get to use that same observation API. We're creating something not started. Because we're not starting this yet, this is actually what kicks it off, right? The observe is what is the code that we're actually observing that we're trying to take a look at. And that is the call to another service that is going to load posts. So finally, we need to introduce a local variable here and call this posts because we're going to get that back. And now we can go ahead and save all using the post repository. So with this in place, I think I'm going to go ahead and restart the application. Let's make sure that it runs okay, and it does. I'm going to head back over to Zipkin here. I'm going to run this query, and now you see we have this JSON placeholder load posts. So if we go into there, we can see that the execution of this took 470 milliseconds. Here's that some value, that low cardinality key value that we set. So we can start to dig into that as well. We don't see the repository happening, so let's go ahead and do that as well. So let's get rid of this and say observation.create not started. Again, we're going to say post repository.save all. We're going to pass in the observation registry. And here we're just going to observe. We don't need to set any key values. This is, again, takes the supplier. So I'm going to say post repository.save all, and we're going to pass in posts. We don't need to return anything here, so that should be good. Let's go ahead and run this again. And we'll run back over to the browser, take a look at Zipkin. And now we see this post repository.save all. So if we dive into this, we can see what happened. There's a connection. Here's everything that happened in our application. So cool. So again, I think one more thing I just want to point out is in application.yaml, in the final version that you will see over on the repository, I'm going to include a little bit more configuration. So let's just go ahead and paste that in. You can find out more about this in the documentation that I linked you to as far as setting up the JDBC logging or JDBC instrumentation. So a whole bunch of properties here that can kind of fine tune that. I set up a separate logger called data source query logger. It's using SL4J. Do you want to include the bind the parameters values in those spans? You could set a JSON format on. You may not want to include everything in that logging. So do I want to collect data on all the connections, fetches, and queries? This is what it's going to include by default, but you could just say, hey, I just want queries. And then now that I have that logging, that logger, I can go ahead and set that log level for data source query logger. So just some additional configuration you can have, which again is nice because now you can have separate configuration for development, testing, and production. So cool. So I included some links in the GitHub repository. This is really just the tip of the iceberg. Observability between logging, metrics, tracing, more importantly, distributed tracing is a huge theme in Spring Framework 6, Spring Boot 3, and all of the portfolio projects across the ecosystem. The next feature we're going to look at is problem details for HTTP APIs. And a common requirement for REST services is to include details in the body of an error response. The Spring Framework suggests and supports the problem details for HTTP API specification, which we're looking at here. Now, I'm not going to go through this whole thing, but this is a really nice spec that talks about what the problem details specification is. It goes into kind of the introduction, what you might want to use it for. And hey, a lot of the times we get this response that has a 403, and it doesn't have a lot of information in it. And we want some more information in it. So how can we do that? So read through the spec if you want. You do not have to read through the entire thing. I've read through like the first 3 sections, and that's really all you need, and to understand what you can put into a problem detail. So we're going to look at kind of a trivial example here, but it will make sense and give you a little bit more insight into what this problem details can do. So here in my post controller, I'm going to create a new method here, and this is going to have a get mapping of /id, and this is for when I want to find a particular post. I may say public post find by ID. From the path variable, I am going to get an integer called ID. And what I want to do is return from the post repository. I'm going to call find by ID. I'm going to pass in the ID. This actually returns an optional, so optional of type. So what I want to do is say, or else go ahead and throw an error. And what is that error going to be? So again, else throw takes a, well, that one doesn't. This one takes a supplier. So we can go ahead and say, I want to throw a new, so I could throw a runtime exception here, but I'm actually going to throw a new post not found exception, and we'll pass the ID. So I'm going to go ahead and create this. So I want to create this. Let's go ahead and create a new package. We'll call this exception, and we'll say new Java class post not found exception. So this is going to extend the runtime exception. And in here, we're going to take in the integer ID. We're going to have a constructor that takes that in. Cool. So post not found exception takes the ID. And then we need a way to get and set that ID. And there we go. So this is saying constructor post, is never used. So there we go. Cool. So now let's go ahead and try to restart our application. And then if you don't know, we do some content negotiation, right? So if we go to all posts, we get those. If we go to posts 99, that is actually a valid one. If we go to 999, we're going to get an error. So we just get this generic error page with a status of 500. If we do this, if you look in the console, you'll see that we've hit that post not found exception. If we run to the terminal, we can do this. We could say, so I'm using HTTP, just an easier way to use curl underneath the in terminal. Curl is kind of verbose. HTTP is pretty simple. So I can just say, I want to call 8080 /API/post/999. And you could see that we're getting a 500 here. So the type is application/JSON. I'm just getting an internal server error. Here's the path, here's the status, not a whole lot of information, right? So one way we could fix this is we could actually come in here and set the response status to HTTP status not found. And if we refresh or restart this application, and then go back to the terminal. So a little bit better. I have a 404. It just says not found, 999, not found. So this, again, is kind of an arbitrary example because I don't have a real example here in the post. But in the spec, there was like a really good example of, hey, you're hitting a forbidden, but why is it forbidden? You don't tell me why I'm not allowed access to this. And in the scenario, I think it was like, oh, you don't have enough money to be able to access this or something like that. So a lot of the times like a 401 or a 403 may not be sufficient. I need more details about why this is failing. And so this is where the problem details comes in. So what I'm going to do is expand upon this. I'm going to create a new Java class in here called exception handler advice. So what I'm doing here is saying that this is a REST controller advice. So this annotation, if we go ahead and look at it, says this is a convenient annotation that is itself annotated with controller advice and response body. Types that carry this annotation are treated as controller advices where exception handler methods assume response body semantics by default. So at the end of the day, we're just allowing a way for us to catch these errors and provide a little bit more detail in this case. So what I want to do is in this class, I'm looking for an exception handler of type post not found exception. So anytime a post not found exception is thrown, this is going to get called. So what I'm going to return from this is a problem detail. So this is the new part, this problem detail class. If we jump in there, represents a representation for an RFC 7807 problem detail. That's the spec that we looked at. And a properties map for additional non-standard properties. So to be able to include those standard properties are things like title, status, detail, instance. And then if you want to attach non-standard properties, you can use this properties map. So let's go ahead and say let's call this handle post not found exception. This is going to take a post not found exception, E, and that's good. So what we want to do now is create a problem details. So we can say problem detail dot for status and detail. So again, there are some helper methods in here. This one is going to take in a status code and the detail. So in this case, the status code is going to be not found. HTTP status code. Why am I status not found? And then e.get message. We'll just get the message from our post not found exception class. Okay, so there's our problem detail. Let's create that problem detail. At the end of the day, we're going to return that. That is the requirement here. We are returning a problem detail. So I can also add information to this if I wanted to. So I could say problem detail.set property. So I want to set this property. I want to go ahead and say the post ID is equal to get ID. And then there are types. So the type is, again, back from the spec. If you wanted to point someone to some documentation that clearly and explicitly defined what was happening here, you could do that. So I could come in here and say set the type. And this would be a URI. So I can say new URI. And this would be to something like localhost 8080 /problems /post not found. Now, I'm not going to include this, but if you are going to include the type, then you should include that. In this case, we also have to go ahead and add that exception. And cool. So I think that's all we need to do there. Yeah. So that looks good. So now, because of this REST controller advice and this exception handler annotation, when this gets caught, we should see that. So let's go ahead and restart this. And go back to the terminal. I'm going to clear this out and run that again. Now you can see the content type is application/problem JSON. So this is the content type. And we get some more info here. So here's the instance. Post ID is that thing that we added to it. Here's the status. Title, so we could change that if we want. Type, here is some more documentation on why this error is being thrown. So again, when it comes to HTTP APIs, just being able to supply more information of why this result is happening is a good thing. So this allows us to do that. I'll also mention that you'll want to go into, I think, let's say, this is by default, so problem details is, looks like it's off by default, but I do want to enable that. So that's a Spring MVC problem details enabled equals true. So you want to make sure that is set. So cool. Again, I've included some links in the README to the documentation on the Spring Framework side, as well as that RFC. Don't read the whole RFC unless you're an RFC nerd, then go ahead. But just the first couple of sections that really kind of talk through the problem and what problem details solves is good enough. So cool. So that's problem details. Let's go ahead and move on. The last thing I want to mention are some changes in Spring Security. Now, I've done a full video on this, so if you want to check that out, I'll leave a link to that in the description below. But I'm going to quickly cover that here just because you are here. Why not? Let's take advantage of it. Our time together is limited. Let's go ahead and talk about it while we're here. So I'm going to go ahead and include Spring Boot starter security. There we go. Security. No, that's not what I wanted. Security. That's what I wanted. Now let's refresh this. Everything looks good. And if we go ahead and start this application, we know that by using Spring Security in the past, we have some things secure for us. So we're secure by default. We get this default secure user or default user with the username of user and a password that is generated for us each time. Now, what is going to change is at some point, we're going to have to provide our own configuration, right? So we're going to come in here and we're going to create a new Java class. We're going to call this security config. And in the security config, we used to extend the web security configure adapter. You can see that's no longer a choice. This was deprecated at some point, and we were still able to use it in versions prior to Spring Boot 3.0. But Spring Security 6 has removed this. So this is no longer something you can use. You need to move to a new model, a more component-based model of declaring beans in your configuration. So to make this happen, we are going to enable web security. This is going to be a configuration class because we are going to create some beans. And then to do so, we'll create a bean of type security filter chain. We'll call this security filter chain, which takes in HTTP security. And at the end of the day, we are going to return http.build. This is going to throw an exception. And then when we come in here, this is where we start to configure Spring Security. So that is the first change, that web security configure adapter not only deprecated, but removed. All right, and so the next thing is we used to come in here and say authorize requests. You can see there's a strike through that. It says that has been deprecated. We want to move to authorize HTTP requests. So now we can come in here and we could say auth.any request. Go ahead and make sure we're authenticated. So that's number 2. And finally, in number 3, when we wanted to use some type of matcher. So we had, we wanted to take a look at, okay, for home, I want you to go ahead and permit all. We used to use maybe an ANT matcher, an MVC matcher, a regex matcher. Those have all been deprecated and removed in favor of request matchers. So we want to use a request matcher now. And if we wanted to say, hey, the root for this project, I want you to go ahead and permit all to that. Anything else is authenticated. So number 1, web security configure adapter has been deprecated and removed. Instead of authorize requests, you want to move to authorize HTTP requests. And instead of using ANT matchers, MVC matchers, or regex matchers, we want to use request matchers. So that's it. Just wanted to kind of quickly walk through some of the changes in Spring Security 6. Again, if you go check out that video, we talk a little bit more in depth about that and link to the release notes for Spring Security 6 where you can find out all of the changes that have happened in it. Wow, that was a lot. And congratulations to you. If you are still watching this video, you are a true Spring Boot fan. I'm a big fan of yours now. So as I said at the beginning, this wasn't an in-depth dive into every single feature. We didn't even cover everything that's in Spring Boot 3 and Spring Framework 6. This was more of a, hey, here's what's new in case you weren't aware of some of these features. Some of these we could spend long deep dives into, like observability and generating native images with GraalVM, but we can't. So what I want to hear from you in the comments below or on Twitter, reach out to me. What are you excited about when it comes to Spring Boot 3? What features are you really excited about? Are you going to make the upgrade? If so, what features are kind of driving that for you? So that's one. Two is, anything that we covered today, was there anything you didn't quite understand? If there was and we need to do a little bit more of a deep dive, that's fine as well. Again, let me know in the comments below. But friends, as always, if you found value in this video, do me a big favor, please. Go ahead and give me that thumbs up on this video. Subscribe to the channel so you don't miss my next video. And as always, happy coding.